Hello, everyone. Welcome to the webinar this morning, where our subject is airspace integration of launch and reentry operations. We're pleased to be able to offer this to everyone in our international community. We know that airspace integration for commercial space launch is a very important topic for everyone. And we want to welcome you guys to joining us and thank you for joining us, regardless the time of day. I know some of you are very early in the morning or very late in the evening, and we appreciate your time. We are recording this webinar, so it would be available for additional reference for either you or colleagues that you may have that may not have been able to join us today. And we thank you for your time. I'd like to go ahead and introduce our speakers for this morning. Our presenters we've got Emily Cisneros. She is an aviation technical systems specialist in the area of airspace integration for the FAA Office of Commercial Space Transportation. And we also have Dwayne Freer, who is the manager of the FAA Air Traffic Organization Space Operations Group. And both of them will be providing some great information today. We will be taking questions. On your Zoom, you will see a chat button at the bottom. They'll all be written questions. So please, as we go through this, enter your questions into the chat. We will take them as we can. And if we don't get to everyone's questions today, we will do our best to try to follow up with you after the fact. But without further ado, I'd like to hand things over to Emily. Is Emily on this morning?
Yes, I am. Working on getting everything set up here.
Very good. Thank you, Emily.
Thank you, Pam. And yes, welcome everybody. Good morning, good afternoon, wherever you all are located. Okay, can everybody see my screen?
Yes, we can see it.
Okay, the presentation view, because my computer just glitched. It seems to not show it, but
yeah, no worries. We can see the presentation
and it looks good. Okay, great.
Mm-hmm.
So thank you, everybody. Emily Cisneros. I am with the FAA Office of Commercial Space Transportation. I know the focus is on airspace integration, so Dwayne Freer will be providing a great in-depth presentation on that. I'm just going to do a very quick overview of our office, who we are, what we do, and then I'll hand it over to Dwayne so that he can jump right into that airspace integration. So who is AST? So AST is the FAA's internal name for the Office of Commercial Space Transportation. We are one of 5 lines of business within the FAA. And on behalf of the Department of Transportation, we do license commercial launch and reentry activities, as well as launch and reentry sites that are carried out by United States citizens and/or companies. Our mission is to oversee and enable the safest commercial space transportation system in the world. Oversee means we authorize through a license or permit, regulate, as well as inspect. Enable means we do it efficiently, effectively, expediently, and we do facilitate. And safest means protection of the public property as well as U.S. interests. Since 1989, we have licensed and/or permitted 517 commercial space launches and/or reentries, and we have 14 spaceport operator licenses. To date, AST has a 0 public casualty and or major property damage record. The types of activities that we are involved in: commercial launch reentry licenses. That includes expendable launch vehicles, reusable launch vehicles, air launch vehicles, experimental permits, spaceport licenses, which are both launch as well as reentry sites, safety element approvals, inspections for launch and operations as well as sites, and payload reviews. Who needs a license or a permit? If a company is United States incorporated or operated in U.S. territory, it needs an authorization. So that means U.S. citizens or entities organized under the laws of the United States or any state must obtain a license to launch or re-enter a vehicle inside or outside the United States, to operate a launch, spaceport, or reentry site, as well as inside or outside of the United States. A foreign entity that wishes to operate a vehicle or site within U.S. territory. An entity may obtain an experimental permit And that's to launch a reusable suborbital vehicle from the US for research and development or prior to obtaining an actual launch license. And that's mainly to show compliance with the requirements for a license, eventually for one of our 450 licenses or for crew training. The FAA does not license launches or reentries that the government carries out for government. While NASA, as well as the Department of Defense, conduct their own launches, both are increasingly using commercial space launch services from many of our operators and applicants. So this little graph shows a typical authorization process overview. It's very simplified. There's quite a bit of different areas that we cover in our licensing process, both for operations as well as for sites. But basically, an applicant, when interested, will approach the FAA and we enter into exploratory initial discussions. And the overall timeframe for this entire process is it really depends on the applicant, the type of vehicle, the type of operations, where they're located. It can range from weeks, but it's more typically months or even years to get from the initial discussions all the way to an actual license. So once we meet with an applicant, we get into those initial discussions as they advance, as their company matures and they advance and they get ready to enter. They get close to wanting to pursue an actual license. The AST will form a team to work with that applicant to cover all areas of licensing. And then we enter stage one, which is our pre-application consultation. And this is the longest part that generally takes months, if not years. We work with that applicant every step of the way to cover every aspect of their licensing. And then when that application is complete, they submit it to us. We review that application. When we consider that application is considered complete enough, we will accept the application, and we have 180 for a license or 120 days for a permit to review that application. And we either accept it or reject it with the feedback and provide the applicant the incomplete items that they need. And then at the very end of that, we get to the license actually being issued, and then stage three, the final stage, would be the operations of that license. So this is a very quick, brief overview of that process. So airspace integration, the reason we're all here today. So per our CFR 400 regulations, an applicant must complete a letter of agreement with the FAA Air Traffic Control Office having jurisdiction over the airspace through which their operations will take place. And this is to establish procedures for the issuance of a notice to an air mission, otherwise known as a NOTAM. A NOTAM defines the lateral confines of the airspace closure with the associated dates and time for a launch or reentry operation. And they must be issued well in advance of operations to notify other users of the national airspace system of the airspace closure. And it does apply to the following for launch and reentry. And I've just outlined some of our various 400 regulations that this requirement applies to. During our pre-application phase, our AST licensing team will work with the commercial space applicant and bring in the FAA Air Traffic Organization, another line of business within the FAA, for airspace integration. The Air Traffic Organization is responsible for ensuring the safety, efficiency, and capacity of the National Airspace System, otherwise known as the NAS. And FAA ATO will work with AST as well as the applicant and any other involved parties whose airspace may be impacted by that operation to develop a letter of agreement with the applicant that meets our CFR regulations. So some key takeaways is AST has a dual mandate to protect the uninvolved public and encourage commercial space ops. We do authorize space operations. We do not certify space vehicles, and we do not authorize military or civil launches and reentries. All U.S. incorporated commercial operations need an FAA authorization, regardless of launch or reentry site anywhere in the world. The overall industry cadence is steadily increasing with great potential. And for those interested in further information on the licensing process or anything related to AST, more can be found at our website. It's at faa.gov/space. And also there's another link that has some additional answers to some frequently asked questions. So does anybody have any initial questions? Okay, well, thank you for your time. I'm going to hand it over to Dwayne Freer of the Air Traffic Organization.
Thank you very much, Emily, and greetings to everyone today. It's my pleasure to be here. As Emily mentioned, I am the Air Traffic Organization's Space Operations Manager. And we'll start the presentation here. And if I can get a thumbs up, Pam, that you can see the screen when you can see it, we'll proceed.
Yep, I can see it. Thanks, Dwayne.
Okay, perfect. It's my pleasure to be here and happy to talk to everyone regarding airspace integration of launch and reentry operations. This is a very evolving field. We're learning every day about how to integrate the operations both safely and efficiently into our national airspace system. For today, the agenda will be as follows. This is more or less in a chronological, this is the order that we follow as we're working with operators and we're developing our integration plan for a mission. We'll start out with an overview today of who we are and what we are, and then we'll go into the process of integrating operations. We start out with, as Emily mentioned, during that pre-application process, the onboarding of the operator and the establishment of a letter of agreement. We'll talk some about risk assessment and aircraft hazard area development, followed by mission planning, traffic flow management, real-time support of missions, and then post-operational analysis of those missions. As Emily mentioned, we have two lines of business predominantly involved in this. There are other lines of business that do have interests in our stakeholders in the process, but for this discussion, Emily covered the Office of Commercial Space Transportation on the left-hand side, and then the Air Traffic Organization is predominantly what we'll be talking about in this briefing this morning. The ATO is charged with integrating launch and reentry operations, both commercial and non-commercial missions, into our national airspace system. We are within the ATO System Operations Service Unit, and then we do have our own space operations office that I lead that is charged with the safe and efficient integration of operations. We work for, some of you may be familiar with the Air Traffic Control System Command Center in Warrenton, Virginia. It's where we do our mission of maintaining and managing our national airspace system. Our space operations office is within that same building and integrated with the other components of that facility. We follow a six-step process for our mission planning and integration. It begins with more or less the notification from the operator of their intent to launch. We do an extensive evaluation of the mission. There's a decision-making process in collaboration with the operator based on that evaluation. Our main product is the airspace management plan, and we'll go into more detail on what that is. But that's our byproduct that messages to stakeholders, various stakeholders, that the mission is proceeding, how it's going to be managed, and other specifics. And then we go into real-time support of the operation, and I'll show you what that looks like in some future slides. And then we do a very robust post-operations analysis. That's key as we're learning and growing this field, is that we robustly look into the operations and any lessons learned, and then we can improve our processes based on those lessons learned. Our job in a nutshell, a picture's worth 1,000 words. These are the U.S. spaceports, launch and reentry sites around our nation. We have some of the legacy sites, the federal ranges at Wallops Island, Cape Canaveral, and Vandenberg. We also have commercial locations that have been licensed by the Office of Commercial Space Transportation. And then we also do have some exclusive use sites around the country. So very, very robust, very integrated operation. And our job within our office is to integrate the operations to and from those locations through the aviation community that we have on any given day. So it's a very complex mission, is integrating those operations through the aviation that's in the system at any given time. And that, I thought that picture just says volumes about what the challenge is. You're going to hear two common themes today. One of them will be around shared situational awareness. And that's amongst the operators, the ranges and spaceports, and our air traffic control units. And then collaboration. We have begun, and we've very much put an emphasis around collaborating between operators, ranges, spaceports, and air traffic control, and other international stakeholders. This has been key to making progress into the safe integration of these operations, is the collaboration and the back and forth and discussion that occurs during the mission planning process. So the first module will be around operator operational onboarding. And as Emily mentioned, during the pre-application process, part of the licensing is the establishment of a letter of agreement with the overlying air traffic control facility. That's a key part of that licensing requirement. And within the letter of agreement, that contains more or less roles and responsibilities, both during the planning process and then during the execution of the mission. You can see the responsibilities both include responsibilities for operator, ATO Space Ops, and air traffic facilities. We have points of contact, personnel training, and then we have procedures within there. The mission planning process typically includes things like time requirements, how far in advance an intent to launch needs to be submitted, and then the notification process of mission and timelines, mission information. A key component of that letter of agreement is NOTAM processing, and that includes international NOTAM processing. Real-time conduct of the mission. We actually have within our real-time support, we have operators on a phone line with us giving us real-time call-outs of the progress of their mission. And we'll go into that a little bit deeper later on in the briefing. And then, as I mentioned, we have contact information in that letter of agreement also. The collaborative engagement during that process, during the development of that LOA, is very critical to establishing a good LOA that meets the needs of our own agency and the operator. It involves mission description and goals, and learning about the operator and what their goals are and what their mission looks like. We discuss notional hazard areas, or the areas that we will need to protect during the mission. And then we exchange, the exchange of contact information is critical there. The next module is around risk assessment and aircraft hazard area definition. This is really the start of our digging into a mission. We have to define what airspace needs to be managed and how it's going to be managed. Right now, the risk assessment is performed by the operator, the range, or the spaceport, and or the regulator. So there's a combination depending on the location and the mission, who's performing that risk assessment, but that's all under the umbrella of the Office of Commercial Space Transportation. Those assessments include both air, sea, and land. Today, we'll focus only on the air side of that. And after those risks assessments are done, an aircraft hazard area is defined. And it's defined by regulation as policy within our regulation as a 1 × 10⁻⁶ result for casualty producing collisions. So that's our current policy and regulation. The ATO, or Air Traffic Organization, has a target level of safety, which is 1 × 10⁻⁹. So recently in 2018, we adapted acceptable level of risk for space operations. And the acceptable level of risk was a policy that was developed to bridge the gap between the regulatory requirement of 1 × 10⁻⁶ and the ATO target level safety of 1 × 10⁻⁹. That's a very complicated discussion, but we have some slides in here, and I'll try to do it justice in a couple slides, but we'll talk about that also. And then the risk assessment not only defines the lateral boundaries of that aircraft hazard area, but it also includes debris fall times. So we both have debris fall times for nominal missions, for jettison type items or payload fairings. And then we also have debris fall times in the event of a malfunction. And those are critical to managing the system and maintaining the safety of the operation. Here's an example of a risk assessment that was performed in the graphic depiction of that risk assessment. And what you see here is a launch operation from the coast of Florida, and the risk contours extend to the east for quite a ways. The regulatory requirement or policy requirement of 1 × 10⁻⁶ is indicated by the light red contours, and the yellow contours indicate the 1 × 10⁻⁷, and the green are 1 × 10⁻⁸. Those are the contours we use, the 10⁻⁶ and the 10⁻⁷, as part of our acceptable level of risk process. Once we receive these in air traffic, we also receive what is called aircraft hazard area. And those are the volumes of airspace that protect the regulatory requirement of 1 × 10⁻⁶. So you'll see some outlined areas in red. Those are the AHAs. On the next slide, we have different types of AHAs. We have this ascent AHA that's basically protecting the volume of airspace needed for the vehicle to launch and begin its journey to space. You also see to the right of that a jettison item AHA. That's to protect payload fairings, skirt rings, different objects falling down from the vehicle. It also can produce, in the case of one operator that is using reusable vehicles, their landing, their return from orbit with their stage 1 and landing on a barge. And then on the right-hand side that might be of interest is also a reentry HA. If there's a second stage or a reentry vehicle associated with the mission, we'll quite typically have what we call a reentry AHA. And this one is actually divided into 3 different FIRs and ANSPs that manage that airspace. So the NOTAM process and the coordination of those reentry AHAs with our international partners is key to the mission planning. The next slide is regarding our acceptable level of risk that I mentioned earlier. Again, ALR was developed to bridge the gap between the current regulatory requirements and the ATO target level of safety. The 10⁻⁷ areas, the ones in yellow here, are what we've labeled those as debris response areas. And we use those as contingency areas in the event of a launch malfunction. We have another slide following this, but this is the first time it was incorporated in April of 2021. And this is the first capability the Air Traffic Organization has had to actually respond in the event of anomaly on launch. The 10⁻⁸ areas are the green areas on the top screen. We monitor the number of aircraft that go through that area, and we manage that as part of a collective risk assessment. We currently limit in any 12-month period the number of aircraft that can proceed through that green area or the yellow areas to 6,412. And that was all part of the risk assessment that was performed when we developed acceptable level of risk. This is a screen that shows those debris response areas. We have 3 areas for this mission that's shown here. The first area, the DRA number 1, is for launch, and it covers the period of time from launch to 60 seconds. DRA 2 goes further than that, and it covers a time period that's longer, up to 180 seconds, so up until 3 minutes. And then DRA number 3 covers the time period after 3 minutes or 181 seconds. And again, those areas are in the event of an anomaly. We activate those, and our air traffic controllers have procedures for the evacuation and the cessation of traffic proceeding through those areas.
Hey, Dwayne.
Yes.
We've got a couple of questions in the Q&A.
Great.
Can
Absolutely.
you click, I didn't mean to interrupt. Can you click on the Q&A and take maybe the first question?
1 second, Pam. I think I've lost my Q&A, my chat screen. So
It's the Q&A button at the bottom. It's next to the chat button.
yeah, I just lost it. So I'll be right there.
Thank you.
I've got it now. Okay. Do you conduct an analysis of the impact to the NAS before you approve a license? Not before we approve the license, but before we approve the mission. We do a NAS impact analysis that's coming up on some future slides. So I'll run through that with you and hopefully answer that in a little bit more depth in a couple slides here. How many launches have employed the DRA model? To date, we've only had 1 launch with a malfunction where we deployed a DRA. Since its inception, that's the only one that a DRA has been used for. We have the DRAs available to us for every mission, but we've only had 1 anomaly that required the activation of a DRA. How do you deal with non-controlled airspace? That's a good question. That's a really good question. So our oceanic airspace, where we don't have tactical control of aircraft, we only use the 1 × 10⁻⁶ hazard area. Since we don't have the ability to respond to an anomaly in non-radar airspace or oceanic airspace, that is not a part of the processes for that airspace, and we block our 1 × 10⁻⁶. If it's a non-radar airspace in our domestic airspace, we have other ALR procedures that dictate the angle of attack and how aircraft proceed through those 10⁻⁷ hazard areas. So it's a little bit dependent on which non-radar airspace is, whether it's domestic or oceanic, but there are 2 different ways of working through that. Okay, I'm hoping I hit the points there, and if that's good, we'll
Yeah, I think so. And we'll keep an eye on the Q&A for you.
Okay, thank you very much.
Mm-hmm.
This is a part of the risk assessment that we discussed in a previous slide, the risk analysis. This shows the nominal malfunction operations and the nominal operations and that debris fall time. So for the ascent portion of the mission, typically about 3 minutes is the activation for on a nominal mission. In the event of the stage 1 or the jettison item area has a nominal time of 25 minutes. And then we go to what if there's a malfunction on launch, and what's the debris fall time or maximum closure time in the event of a malfunction. Those are the areas that are circled, or those are the values that are circled in red. Those indicate the number of minutes that air traffic would have to block that airspace in the event of a malfunction, both for the ascent portion of the ascent AHA and the jettison item AHA. Now we'll get into more of the mission planning process. We've defined the AHAs now. We know the airspace we need to block. We know the amount of time that needs to be blocked. And then now we go into that mission planning process. And I think we'll answer that question about the NAS impact or the impact analysis during these slides. And again, it's a 4-step process. We are notified by the operator of their intent to launch or re-enter through the National Airspace System. We evaluate the mission based on the information that we received, those same hazard areas and the debris fall times. There's a decision made whether we need to work with the operator on shortening the window, moving the window, or whatever we can to mitigate any type of impacts that are associated with the mission. And then again, our main byproduct of that is our airspace management plan that we produce, and we'll go through each of these individually. The first one is the intent to launch, and typically in an operator intent to launch, we receive the primary launch date and any backup dates associated with that mission. We receive the launch window, or the time they intend to operate, and then that will generally also include intended launch times, or T0s associated with that mission. We receive the risk analysis, what we talked about in the previous slides, the AHA definition, the nominal closure times, the malfunction closure times, and then if there is a reentry, we receive the times for that reentry. So what we do with that is we take that information and we build it into our mission plans. We define the hazard areas, and you'll see the screen that you saw previously with those 3 different types of hazard areas. And we've done now the math. We've received the launch window, we've received the malfunction times, and we add those together and we come up with a activation time for those hazard areas that you can see at the bottom of the screen. So that the full time for that hazard area activation is the launch window, in addition to that debris fall time, that maximum debris fall time that would be required if there was a malfunction. So that is the complete time that air traffic has to block that airspace, even in the event of a malfunction. And defining those times is key, because now we've got both a start time and end time. And that leads into what we'll talk about when we get into traffic management. It will lead us into a time-based solution for managing traffic in and around that airspace. And that's where we've over the last several years, that's where we've really gained our efficiency, is being able to define those exact times and managing aircraft and airspace to those times. Here's 2 examples of our assessment tools. On the left-hand side is ACAT. It's a assessment tool that we use. And it's more or less, we put the dimensions of the hazard area onto a mapping system. And then based on historical data that's resident in our systems, we're able to predict, based on similar days, similar times, we're able to predict the number of aircraft. We can even drill down into the type aircraft, what airlines are most impacted, what airports, departure airports or arrival airports might be. We can even get down into airframes based on the historical data, how many airframes and what type of airframes will be impacted by that mission. It's a very robust tool, but that really allows us to do a complete analysis of that mission and determine what the impacts to the airspace are. I'd like to hear from, I believe it's Jen's submitted the question on impact, if we're answering that question in these slides. We also have another tool that's a similar type of tool, but does a little bit different analysis on the right-hand side. And that more or less defines the same thing. You can see in that lower right-hand corner, we've put in a hazard area with a launch window and a hazard area activation time. And we've done an analysis for 30 similar days. So if the launch is on a Tuesday afternoon between 2 and 4 in the afternoon, we'll do an analysis of the 30 previous Tuesdays between 2 and 4 in the afternoon. And what you see there is a graph of the total number of aircraft impacted by that mission. And then on the left-hand side, you'll see the actual call signs, what aircraft, what companies, what are the departure points and destinations defined within that. So we have a very targeted capability now as we move forward into real-time support of being able to identify exactly what aircraft are impacted. So we only move the minimal number of aircraft necessary, and we maintain the efficiency of the airspace as the mission proceeds. The next slide, a very important part of this and something that's been developed over the last couple of years, is the international coordination of missions. When we do have a reentry or a hazard area that falls within another FIR or flight information region, we'll coordinate with that flight information region. We start generally 10 days prior to the launch date. We submit that information through our US NOTAM office and the AMHS, Aeronautical Messaging and Handling Service, to get that information to the other international service provider. We also use other forums. We have Cadena work group, ISPAG, and Cadence, or other avenues that we use that we can message through, and we can collaborate with our international partners on the establishment of a danger area, the publication of a danger area, and really getting the notification. We've made really fantastic strides within the last year in improving the process, in collaborating with our international partners. And if I can be so bold, Ms. Hannah Brown, who's on here with us, has been critical in that function and establishing those processes and really creating more harmony across the globe and collaborating in a much more successful way. The next slide is a—
Dwayne, can I interrupt you again for a couple questions? Sorry about that.
Sure thing.
So I'll read a couple for you because there's quite a few in the queue, and we'll try to get some of these off if that's okay, Dwayne.
I wasn't scrolling down, Pam, so I'm with you. Okay.
Yeah, I'll just read them to you. Hopefully that'll help you out.
Okay.
We've got a question here that says, great work for safety conducting space launches, but airspace restrictions are applied for a much longer duration is the question. So are they applied for a much longer duration than the space launches? And then the follow-up to that is, what is typical NOTAM airspace closure duration? So it's really about duration of closures. It's the one from IATA.
Yeah, that's a great question, and happy to answer that one. Our NOTAM airspace closure is the time, what we showed earlier in the previous slide. It includes the launch window and the debris fall time. So that's our NOTAMs match those times exactly. In the past, that was not the case. In the past, they were NOTAM for greater durations. But over the last 4 years, we've actually narrowed down through the collaboration with the ranges and the operators. We've narrowed that down to be very specific and only closing the airspace for the time necessary to accomplish the mission and protect in the event of an anomaly. So I think we've done a great job of really narrowing that down and getting it to that very specific times. And we should not see any additional times on top of that.
Great, thanks, Dwayne. And then why don't we go to the next question there? How does this management process work where a launch is conducted from outside the United States and scheduled debris is planned to fall within a US FIR, for example, oceanic area?
In that case, we receive through our NOTAM office, we receive the hazard area or danger area from the other ANSP, or and they give that to us, and we'll publish that in advance of that mission. So we're on the receiving end of that diagram that showed the flow of information for the hazard area. So we receive that internally, and we'll put out our own airspace closure for that.
Thanks, Dwayne. Another one here from Andy Smith. Does the mission sponsor, AST or ATO, designate the different safety hazard areas? For example, 10 to the -6, -7, -8, etc.
I'm not sure I understand. Let me read that one more time. Does the mission sponsor, AST, or designate the different safety hazard areas? So the calculation is done. It's and Pam, help me out here if I get this wrong, but it's overseen by our regulatory.
Correct. So the space law requires, commercial space regulations requires a level of safety of 1 × 10 to the -4. That's in our FAA regulations. But then, as Dwayne indicated in his presentation, the execution or the implementation of that does require, and tell me if I say this wrong, Dwayne, that hazard area to be reassessed using that 10 to the minus 7 assessment. That's what you went over in your calculation. Is that right?
Right, exactly.
And so I believe the nature of this question gets down to designating that. So for the purpose, and Dwayne, tell me if I'm saying this right, for the purposes of implementing the airspace closure, the FAA, and I'll say that generically, the FAA designates that to be at the 10 to the minus 7. Is that, am I saying that right, Dwayne?
The part that's NOTAM closed is the 10 to the minus 6.
Okay, thank you.
We don't NOTAM close the debris response areas. Those are internal air traffic procedures that we use internally, and they're not visible to the external stakeholders because they only involve an air traffic procedure and are not predetermined or not closed in advance of the mission, I guess is the best way to say that.
I think that gets, and Andy, if we didn't hit your question, please type it another clarification in the chat. We'll try to get to it. Stefano, I promise you, I did see your question about LOAs, but I'm not exactly sure what the question is. So if you could possibly rewrite that about LOAs, that would be helpful. And then we can tee that up for Dwayne. So moving on to the next question, Dwayne, because we've got a few, let's get some out and then we'll start back with the presentation. Yeah. How do you deal with launch date slippages? Oh, my screen just moved. How do you deal with launch date slippage and the impact on the traffic analysis? For Mark,
when we receive the operator intent to launch, they'll include backup dates, and we will do an analysis not only of the primary launch date, but any backup dates that are submitted at the same time. So that's part of the intent to launch. Our NOTAMs will also include those backup dates. So you'll quite often see in a NOTAM that primary date with the hazard area window for that primary date, but then you'll also see successive dates, quite typically 5 to 6 successive dates that have, and typically those times will move depending on the type of mission that's being performed, but you'll see those additional times also. So it's done virtually at the same time, and then we will message out in real time if there's a scrub and a move to a backup date.
Super, thanks, Dwayne. The next question from IATA again, what is the frequency of commercial launches? Is it occur every month?
Right now we had 92 launch and reentry missions within the National Airspace System for 2022, the calendar year. And we anticipate that will increase significantly this year. We're roughly gauging around 140 missions this year. So dividing that up, we're 10 to 12 a month from various locations.
Definitely very busy, right, Dwayne?
Definitely busy, yes.
Definitely busy, job security. So we've got another question here from IATA. Do you suggest launch slots when there is less air traffic? Good question.
We do work with operators where they have flexibility and where they have the opportunity to move a mission or alter the time. We will make suggestions to that, and we've gotten it's a very collaborative endeavor, and they're very good with working with us on managing that and trying to mitigate the impacts of operations. A lot of times that's their launch windows are dictated by orbital mechanics, and they don't have that luxury. So we'll work with them. We message to them. We give them high volume days. One of the typical examples is a recent Artemis mission that NASA launched. We worked with NASA very collaboratively to mitigate impacts because it was their operation was around our holiday season. So we worked very collaboratively with them to manage the mission so there was minimal impact on the NASA and certainly on those really high volume days. So that's typical of what we do with all operators. We'll work with those, and if the window and the date are high volume or high impact dates, we'll work with them. And it's been very successful over the last several years in mitigating that. There's certainly times and there's certainly situations, if it's a mission to Mars where the date is absolutely critical and the time is critical, and you're going to lose the opportunity for the next 2 years if you don't hit that date. There are times when the nature of the mission dictates something that may not be conducive or may fall on a high volume day. And what we do there is we start to develop a very robust traffic management plan to mitigate the impacts to the aviation community as best we can.
That's a great answer. And I think that answers the next question from Mark Jones about imposed launch date times based on analysis. So let me jump to the one Mark Jones just asked about what happens if any of those international partners aren't receptive to the airspace closure.
We've worked with several partners. Actually, our international branch, our ATO International, is working as we speak on opportunities in coordinating. We're developing best practices. We're developing regional best practices on notification. So what we've been doing is we've been doing quite a bit of outreach to establish those norms and those best practices. And so far that's been working very good. I think the international community is definitely embracing the engagement in the discussion. And we've learned quite a bit over the last year, and it really is informing our decisions. And quite significantly, we're messaging that also to the operators so they know what the expectations are from the other ANSPs that are involved.
Great, thanks, Dwayne. And then we'll do a couple questions on analysis and then have you go back into your brief so we can, so there's 2 questions on analysis, and I'm going to ask you to do maybe both of them at the same time. How are the malfunction times calculated during AHA activation? And what is the software you use for airspace requirement analysis?
So the first one, I'm going to defer to the malfunction times are calculated by engineers either at the range or within the Office of Commercial Space Transportation. They have, depending on the vehicle and all the inputs into their engineering systems, they're able to calculate those malfunction times. I don't have a lot of insight into that, and it's a very complex calculation. So really, we get the byproduct of that calculation and we implement what's in that. So I'm sorry, I can't go into a lot of detail on that because it's like I said, it's very complex calculation done by the engineers at those locations. And then the software for our airspace requirement analysis, those are proprietary systems. We have a contractor that performs that analysis for us. And then we also have a system that was developed by the MITRE Corporation that does that type of analysis. Those are not FAA systems. Those are systems that have been built by other external entities that assist with that.
Great, thanks, Dwayne. And we'll go ahead and have you get back to your brief now, and then we'll come back to questions in a few minutes, if that's okay.
Yeah. So I believe we were on the airspace management plan. Oops, sorry about that. This is our product. This is our externally facing document that notifies it gives a mission overview, mission schedule, traffic management initiatives, and it's distributed to our launch and reentry operators, the ranges, ATC facilities, the aviation community, or other stakeholders. So this is our external outreach to notify those stakeholders of the mission, the intent of the mission, give them some specifics so they can begin to make their plans for that. The next module here is regarding traffic flow management. This is, now that we have the hazard areas defined, we have the launch windows defined, we've done the analysis and we've worked with the operator on mitigating impacts. Now we're going to go to the next step of managing the traffic flows. And it really is a traffic flow issue. We typically don't have departure delays or other type of traffic management programs. It's really a rerouting or a detouring of aircraft that are affected by the hazard areas that are the primary traffic management initiatives. That's that opening slide there shows you typical flows of traffic and a launch from Cape Canaveral off the east coast of Florida. And what we'll do is we'll, in the upper right-hand side, you'll see a typical flow of traffic. And then the management plan that's put into place will move those flows. And you can see how they shift to the west coast of Florida. And the primary goal there is to mitigate the impacts, mitigate the delays associated with that, but also to balance the traffic flows within the facilities, Jacksonville Center and Miami Center, to ensure that the air traffic control sectors in those facilities don't get overloaded during the times of the mission. So we use time-based procedures. We've had a successful program, time-based launch procedures. We implemented that to actually using the times, the hazard volumes, to actually tactically manage those flows. So we're only impacting those aircraft that are affected and trying to minimize the impact to other areas or other traffic. Real-time situational awareness, I think I mentioned that's one of the key or one of the themes here. That's key to this effort, is that real-time situational awareness. And we'll go into what that looks like later on, but to us, that's how we can tactically and dynamically manage the airspace. That's a capability that's rather new. In 2019, we started establishing what we call launch hotlines, where we have the operator, the range, and our air traffic facilities on an open phone line during the mission, and mission events are called out over that. So the air traffic facilities can very dynamically start managing airspace. Collaborative discussions with the space industry have been critical to understanding the operations and the development of dynamic airspace management procedures. Again, the real keys or the real themes behind this is that real-time situational awareness and the importance of collaboration. Early communication of traffic management plan is key to the aviation industry. Our international partners, our IATA, who's on here with us today, is getting them that information so they can plan their flights, they can do fuel loading, then they can do all those well in advance, and making sure that they have the plan and can make their plans accordingly. This is an example, a little bit of a complicated slide, but our traffic flow management is using time-based procedures, and the importance of the hotline for tactical management and the collaborative decisions with industry. What you see in the upper schematic is a notional hazard area or launch window of 100 minutes. And then the safety letter time at the end, that red box at the end, is a 40-minute debris fall time. So when you add a 5-minute pre-launch buffer, you add the launch window, and then you add the debris fall time, you wind up with a 145-minute long hazard area. Where we're trying to gain efficiency is both on the front end of that mission and then also on the back end of the mission. So what we've been able to do using time-based procedures in tactical management, you can see example 2 there is an example of gaining efficiency on the front end. If the operator tells us in advance through real-time communication and that shared situational awareness that they're going to move their targeted T0 to the back of their window, we'll leave that airspace open on the front end and gain efficiency there. So we're more or less cutting the window down and shortening the window real time and gaining that front end efficiency. On the next slide, you're going to see more or less the same thing, but where we gain efficiency on the back end of the window. One of the key takeaways that we've had over the last year is that real-time release of airspace. We're gaining back often hours that were previously blocked. Previously, we just reacted to, and we had the total hazard area, and there wasn't much efficiency gain, both either on the front end or back end. We've gained significant times, over hours, in our operations by that tactical management. Again, it's real-time situational awareness and the collaboration with industry to make that happen. Do we want to address any questions now, Pam? think we've got most of them so far.
Yep, I'm sorry about that. I was stuck on mute. Why don't
Okay.
we go ahead and go to the one from Sarah Parker. Is the FAA also involved in conduct of a similar analysis for reentry of space objects in general with U.S. airspace?
So this is a little bit of a two-part question or two-part answer to the question. Reentry for planned reentries, we do work with and we block airspace for that in much a similar way as we do for a launch. So if it's let's say a reentry from the International Space Station, we'll work with the operators. We get the same type of hazard area information, and then we will implement very similar to what we do for a launch. Now, there is quite a bit of debris that comes down that is unplanned or unanticipated. We don't have the capabilities and we don't manage that operation by and large because we don't have a defined hazard area. We have some, for unplanned reentries, a lot of times we'll have notional areas, but they're quite large and they span quite often large expanses of airspace of notional reentry points, but we don't have a defined hazard area. So if it's an unplanned reentry or uncontrolled reentry, we don't have the ability to employ these same type of techniques.
Super, thanks, Dwayne. The next question is from Ayada. Each launch means additional cost to the airlines due to the following: cost of extra airborne time, cost of delays. Offsetting the cost impacts on airlines for space launches, those are commercial in nature. Do you have or are you considering a compensation mechanism to offset costs incurred by airlines when avoiding commercial launch areas?
I'll say that one's outside of my pay band. So that's more of a policy discussion. Good question. I know that's been discussed on several different forums, but I don't have a good response to that.
You know, Dwayne, one thing for sure is that is the ATO, and you don't have to say what the metrics are, but, you know, to the point that is being asked, metrics, are we, you know, trying to track the, you know, how many flight delays and things were incurred, so we at least have our arms around, you know, potentially what the impacts are? Is there at least efforts in that area underway by the FAA?
We do. That perfect, Pam, because we work with IATA, with NBAA, with A4A on getting them information on the impacts of the missions and areas where we're gaining efficiency. We have a collaborative decision-making group that we established last year that includes both the launch and reentry operators, the government agencies and government entities involved, and the aviation community. And one of the focuses on that is developing metrics that can measure and really obtain data and measure the things where we can influence further efficiency gain. That's really the key, is how do we improve? How do we move forward? We're focused very much on moving the needle forward and gaining those efficiencies. So great question, and absolutely that's forefront in everything we're doing, is trying to be as efficient as we can and giving that information to the aviation community.
Yeah, and I'll just tack onto that if it's okay, Dwayne. You know, since we're having this conversation about what we do in the United States, you know, potentially applicable to our international partners, these are all great questions. That point about, you know, the FAA effort to define those metrics and keep track of that about efficiencies is really one that we would probably recommend our international partners do as well. Gives you good data so that you can look for efficiencies and then track and see the impact of those. Would you agree, Dwayne?
Yes, absolutely.
Right. So let's go to how does this management process work where a launch is conducted? Oh, I think we already had this one. My apologies. Request to consider publishing, sharing these traffic flow management best practices. It will help other ANSPs. So I'm just curious, Dwayne, if we've ever looked at that.
Absolutely. We have a pretty robust CDM process, and I believe Several international partners have expressed the interest in obtaining that. We've done several briefings, and actually this is one of the primary focuses of this is getting the message out and sharing with our international community. I know our collaborative decision-making, one of our next meetings is going to be focused on inviting international stakeholders in so we can begin that sharing that information and sharing our best practices.
Thanks, Dwayne. That's great. And then again, back out to Stefano. I do see your question here about LOAs. I apologize. I just don't know that I understand it. It's probably referring to a specific side. If you could retype that in, we'd be glad to take that here live. But then back over to you, Dwayne, for your presentation.
Okay, thank you, Pam. We'll move on to real-time support of the mission. Sorry about that. We actively manage the missions in real time. So what you'll see here is depicted is our Challenger room that's at the Air Traffic Control System Command Center in Warrenton, Virginia. And during any launch or reentry from U.S. airspace within the National Airspace System, we stand up or we crew this mission control room. The key tools that we have in here are the Space Data Integrator, our traffic flow management. That's our legacy system that we've used for years to manage airspace in and around the United States. And then we have the launch hotline that I mentioned earlier, and I'll go into more detail on all three of those. The first one is the hotline. It's really an open phone line. It's a Frequentis system that we use. It's a rather robust phone system. But this is the key to real-time shared situational awareness. It was established in 2019. These are the different entities. You'll see we have our own Department of Defense, our air traffic control facilities, federal ranges, the operator. If it's a commercial range, we'll have them on. And again, this is also everyone, all those entities have the same situational awareness real time. The operator will often, we have in the letter agreement, we'll have them make certain call outs to us. Let's say T-minus 10 minutes. We'll have them call out launch. We'll have them call out stage separation and then mission completion. The airspace is tactically managed and released over this hotline. The range will release airspace back to the air traffic system after those debris fall times are exceeded, and we'll release that, and air traffic facilities are on there with us, and we'll be able to start running traffic back through those previously closed airspaces. In the event of a launch malfunction, the DRA, the debris response area, will be activated via this hotline. And again, we'll message that out to our air traffic facilities and the other stakeholders that are involved with that. And they will start taking action based on that call out. Here's a depiction of our Space Data Integrator. This is a new capability. It was fielded on June 30th of 2020. This is a very unique system that was run through our acquisition management process in a very out-of-the-box way. And it's led to really good gains within the system. For an air traffic controller, this is like a new radar system for us. It doesn't use radar, but that's kind of notionally the way we think about it. We receive telemetry data from the operator real time. So from the vehicle itself, it goes to the operator, and then we get the information in near real time. And we're able to display the vehicle, the location of the vehicle, the speed of the vehicle, and the altitude of the vehicle. And then you'll see on the screen, the white lines are the predetermined or the pre-planned paths of all stages of that vehicle. This is a two-stage vehicle. And on the upper left-hand corner, you'll see initial mission events and the timeframes for those. What we're doing there is we're actually managing or monitoring the pre-planned mission events versus what's actually happening. So that gives us more or less of a health status of the vehicle and whether it's performing as planned. So this is a really important new system. We're iterating and improving on that as we go along, and we have those missions, those lessons learned. You'll see in red on the screen are the AHAs that we talked about earlier, and then the white polygons are the DRAs. So you'll see this again has 3 debris response areas associated with this mission. The next screen shows those debris response areas and some of the same information. You'll see in the top upper right-hand corner, in the event of a malfunction, our aerospace engineer in the Challenger room will activate that button, and that will push real-time hazard areas, those debris response areas, to the traffic management units within the facilities that are affected. So that's how we do that real-time communication over the hotline, and we can push that information out to our air traffic facilities, and they can be able to begin responding to any type of anomaly. Again, that's our first time capability that we've ever had to respond to an anomaly, and I think a very important safety enhancement that's come along within the last years. And then the post-ops analysis is one of the really key events that we focus on, the lessons learned, and how do we learn from past missions, both successes and failures. So it's a 3-step process. We do quite a bit of data analysis. We do a replay where we actually monitor the traffic and the vehicle, and we produce a replay of that event, a visual replay, which is it's very critical in learning. It's picture tells 1,000 words, and those replays are really important for our learned success. The team goes through any lessons learned from the mission, and then we develop best practices from that, and we roll those back into future missions. So we're learning from, as I said, both our successes and failures. It's important that we do that. And I believe that's the last slide, and I'll entertain any more questions that we have.
Yeah, great. Thanks, Dwayne. And so we do have a couple questions. It looks like Ayada has asked to share the PowerPoint presentation and the link. I'll tell you that it is our plan to share the recording link, absolutely. And we'll let everyone know when it's available on our website. The PowerPoint is also something we'd be glad to put on the website. We'll just have to go through a little bit of a process to make sure it gets out there and compliant with website regulations. But yes, we will absolutely make sure both of those are available on our website after the fact. So thanks so much for those inputs. Dwayne, here's a question for you. In the event of a launch malfunction, DRAs are activated. How in such a short time do you activate DRA and take aircraft out of the area?
So we did a quite extensive analysis of that. We did a very robust SRM process as part of this. We can get the information to the air traffic controllers. They've already have the debris response areas depicted on their screens. So a controller in Miami Center or Jacksonville Center or whatever facility will actually have those depicted on their screens and are ready to react. All they have to do is get the word. So over the hotline, we'll activate that, we'll call out. So in most cases, we'll be able to get the information to air traffic controllers in under 2 minutes. And then they'll be able to start moving aircraft and keeping aircraft out of that airspace. Notionally, it depends on the type of debris, but notionally, if we have an anomaly at a higher altitude, we'll have 5 to 8 minutes to react to that. And to evacuate that airspace. So we've done human in the loop trials on that. We've engaged with air traffic controllers and had them react to that. And we feel confident that we'll be able to react to that anomaly and both evacuate the airspace and keep aircraft out.
Thanks, Dwayne. Next question is about SDI. Is SDI a web-based technology?
It is not. It's not a web-based. I think there's some discussion within our program management office about expanding that capability, but I don't believe there's any immediate initiatives to make it web-based.
Super. Thanks, Dwayne. Would the recording be available outside the U.S. As being available for the CAA? Yes. So I believe the question from the CAA, Matt, you're asking about the recording of this particular web shop, yes, it's going to be on our website. So you'll just be able to click on the link on our website. Should have no issues whether you're trying to access it either inside or outside the US, because it'll just be on the publicly facing FAA website. Good question. No, thank you. Next question for Dwayne. Are other nations' agencies included on the hotline when they are implicated?
That's a great question and a very relevant question. If you're familiar with the operations from Starbase, Texas, there's hazard areas that will overlie the Merida and Monterey flight information regions. Those are both within CNEAM in Mexico. So we've got a letter of agreement with those facilities, and they will be on the hotline during those missions because of the direct impact and the need for them to have that same shared situational awareness. So yes, where there's a need, we absolutely are including other ANSPs.
Great, thanks, Dwayne. And a question, I believe it's from Eurocontrol. It mentions Hannah and myself at the network manager Eurocontrol have already begun talking about best practices. I guess I'll cue that up for a question to Dwayne. As organizations such as Eurocontrol and others of our international partners here, as they're looking at best practices, I'm assuming, Dwayne, they could submit questions to you or seek advice from FAA on different topics if needed. Have you guys had those kinds of discussions before, Dwayne?
Oh, absolutely. This is a really growing field. And what we want to do is we want to include the collaboration with the international community and share those best practices so we can learn from each other and grow. That's really critical, is that we're not doing this in a vacuum, and that we're sharing our successes and our learned knowledge with those other ANSPs and vice versa. We want to learn from other ANSPs on what's worked for them and what's been successful. So.
Absolutely. And Dwayne, I can say from experience, because you've been doing this for years now, a lot of the procedures we have in place now is because we learned from, I'll just say it, mistakes, things that we realized we could have done better.
Right.
The FAA's, Emily opened this up with saying we've licensed over 500 launches and reentries to date. So we have a lot of experience but we will never say we always have done it right. So the products you've had today are really a byproduct of that, right? Lessons learned and how to figure out better ways to do it.
Anytime you're doing something new in a new field, it's critical that you learn, because you are learning something every time you operate. So that's really I think a lot of these companies, launch companies, are the same. They're learning every time. And if you're not taking in those best practices, then you're really losing an opportunity to move forward.
Thank you. So now we've got a question from Mark Jones. How do you deal with airspace that has overloaded implications? Dwayne, for you?
Overland implications? Yeah.
Overland. I'm sorry.
No
I'm not reading very well this morning.
No worries. So any overland, it's actually, in my view, the overland is a little bit easier because we can more tactically manage than we can, let's say, the discussion about oceanic airspace, where it's more strategically managed. So we'll block the airspace, we'll block that same 10⁻⁶ hazard area, and we'll move aircraft around that and very tactically, very dynamically manage. We have some locations, some suborbital locations, where an operator will have, let's say, a 6-hour launch opportunity, but the airspace is only blocked for 30 to 45 minutes because we're so capable of tactically managing that airspace.
And Mark just asked a follow-up question to that. And close airports, Dwayne?
We will close airports if there's an airport that underlies. Right now, that's not, very few operations have resulted in a closed airport. But that's certainly a possibility where and if the hazard area overlies an airport.
Super. And I think that's the end of the questions I see on the chat right now. I do see the request from IATA to provide the portal link in the chat box. I believe you're talking about the link to the recording, and that won't be available today. We're literally recording it now. So providing in the chat box, I'm not sure would be able to help, but perhaps what we can do is when the recording is available on our website, we'll send out distribution to all that you received invite with a link on an email. So hopefully you should be able to find that a little bit easier. Okay, did another question come in? Yep, thanks so much, Andy. I'm glad that you appreciated the briefing. Dwayne, any other comments from you in kind of closing to this? Because it looks like we have answered all the questions.
Yeah, Pam, I want to really thank Office of Commercial Space Transportation for the opportunity in arranging this. Thank you so much. We have a very good collaboration with your line of business, and I really appreciate the opportunity. And I want to thank the folks that dialed in this morning for dialing in. We've been talking about this. I know Pam and I have been talking about doing this briefing for quite a while, and I'm really glad to see that we developed this. And if there's any opportunity for further exchange or further questions, I definitely want to keep that avenue open and facilitate that. So thank you very much, Pam.
Yeah, great. I couldn't agree more, Dwayne. We appreciate your time today, and of course, Emily as well. Very informative for the group here on the workshop. Dwayne and Emily really are our best. I have a lot of experience. Highly recommend if you have follow-up questions, please, send that in to the email that you received the invite on. We'll be glad to try to get you some answers. Also, regarding the collaboration that Dwayne said we try to do, if you don't know who to talk to, if you're potentially interested in doing some collaboration with the Air Traffic Organization about best practices, you could always just email that address that you received the invite to this workshop. We'll get you to the right persons because we feel very strongly in the FAA. This is a global growing industry, and we want to have consistency in our approaches, and we appreciate the partnership for sure. So I appreciate everyone's time today. Give us till probably some later into next week before we can get the link to the video out to everybody, along with hopefully the PowerPoint slides on the website shortly thereafter. And thanks so much for everyone's time today.